Real numbers. Third part. So, moving on to our next exercise. Real numbers 1.3. Our first question. Prove that root 5 is irrational. So, what we have to prove? We have to prove root 5 is an irrational number. So, how we are proving this? As we proceed in the proof of root 2 is irrational, root 3 is irrational, what we are assuming here? By the method of contradiction, we are proving this by assuming root 5 is a rational number. Okay. So, we prove this result by the method of contradiction. Okay. For that, what we are assuming? Root 5 is a rational number. At first assume root 5 is a rational number. Okay. So, by the method of contradiction, you have to note that why we are moving this method, that is, we have only two results, that is either root 5 is rational or root 5 is irrational. So, that's why we are moving by the method of contradiction here. Okay. Then, if root 5 is rational, then root 5 equal to p by q, where p and q are integers and q not equal to 0. And HCF of p comma q equal to 1, p and q are co-primes. Okay. This is our assumption. Then, what next? We are taking q to the left hand side. Then, root 5q equal to p. If root 5q equal to p, then what next? On squaring on both sides, we will get 5q square equal to p square by squaring on both sides. Okay, 5q square equal to p square. What this implies? 5 divides p square, or p square is a multiple of 5. As in the previous cases, 5 divides p square, since p square is a multiple of 5. Okay. Then, what this implies? 5 divides p by the theorem. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. Okay. In this method, you have to mention what is our theorem is about while writing the proof in your examination, or either you are writing answers to some question. You have to mention our theorem like this. Then, what is next? If 5 divides p, then 5 is a multiple, p is a multiple of 5. That is, if 5 divides 25, then 25 is a multiple of 5. Like that. What we can write then? P equal to 5c. Okay. If p equal to 5c, what next? What is p square? If p equal to 5c, p square equal to 25c square. That is q square equal to 5q square equal to 25c square. Here 5 is common here, 5 is common here, cancelling each other. Q square equal to 5c square. Okay, if q square equal to 5c square, then 5 divides q square, and then what we can conclude? 5 divides q. From this theorem, then if 5 divides q and 5 divides p, what we can conclude? 5 is a common factor of p and q. Okay, what happens? Which is a contradiction to the fact that HCF of p and q is 1. That is, p and q have another common factor, which is 5. Okay, if 5 divides p and 5 divides q, then p and 5 has a common factor 5. That is, what is our assumption? What is our definition here? HCF of P comma Q equal to 1. But here we got the highest common factor is 5. Then which is a contradiction to the fact that HCF of P comma Q equal to 1. It can be 5 or more than 5. So our conclusion, hence our assumption that root 5 is rational is wrong. Okay, then what is other? If it is wrong, then what is the other result? Root 5 is a irrational number. So our next problem. Prove that 3 plus 2 root 5 is rational or irrational. Then for proving this theorem, at first what we are moving on the method of contradiction, and for that we will assume we prove this theorem result by the method of contradiction, and for that we are assuming 3 plus 2 root 5 is a rational number. That is, at first assume 3 plus 2 root 5 is a rational number. Then what next? 3 plus 2 root 5 equal to P by Q, where P and Q are integers and Q not equal to 0. Also one more thing, that is HCF of P comma Q equal to 1. Then what next? We are taking all the integers to one side. That is 2 root 5 equal to P by Q minus 3. Okay, or P by Q minus 3 equal to 2 root 5. Then by taking LCM we will get P minus 3Q whole divided by Q equal to 2 root 5. Now taking 2 to the denominator, we will get P minus 3Q by 2Q equal to root 5. So what we get? P minus 3Q by 2Q equal to root 5. That is root 5 equal to an integer by another integer. Okay, that is Q not equal to 0 implies 2Q not equal to 0. That is, a number is rational if it is equal to an integer by another integer. Similarly, we got root 5 equal to an integer by another integer and the denominator is non-zero. Then what next? Hence, root 5 seems to be a rational number, or we proved root 5 is a rational. So our assumption is wrong. So we get something wrong here, that is root 5 is rational. So why we got that thing? Because our assumption is wrong. Okay, we are moving in the wrong path. So, which is a contradiction to the fact that root 5 is an irrational number. And so our assumption is wrong. So, if our assumption is wrong, what we can conclude? 3 plus 2 root 5 is a rational number. It's an irrational number. So, hence 3 plus 2 root 5 is irrational. So, we have proved our result here. Please keep this in mind. Okay, moving on to our next exercise. Prove that the following are irrational. Okay, we have three questions here. 1 by root 2 equal to 7 root 5 say 1 by root 2, 7 root 5 and 6 plus root 2. Okay, let us proceed with the first question. Then, that is, here also we are applying the method of contradiction as usual. Okay, for applying contradiction, what we have to assume? 1 by root 2 is a rational number. Okay, why we are applying the contradiction method? Because we have only two options. Either 1 by root 2 is rational or it can be rational. So we are applying this method of contradiction method. So what we have to prove? We have to reach a contradiction. That is, we have to prove something wrong by going this way. Then, what is next? At first assume 1 by root 2 is rational. What is next? Then 1 by root 2 equal to P by Q. P and Q are integers, Q not equal to 0, then HCF of P comma Q equal to 1. Okay, P and Q are coprimes. This is our usual step. What to do next? It is a very simple problem to proceed. That is, what we are going to do is, we are taking at first this thing that was 1 by root 2 equal to P by Q. That is 1 by root 2 equal to P by Q. Then what is next is, we are taking reciprocal of this. Okay, that is, what's the reciprocal of 1 by root 2? Root 2. Reciprocal of this P by Q? Q by P. That is root 2 equal to Q by P. So root 2 equal to Q by P. That is, Q is an integer, P is an integer. But there is a problem. P not equal to 0 is not confirmed here. But can P be something equal to 0? No. Why? If P equal to 0, this whole term equal to 0, then 1 by root 2 equal to 0. That is not possible. So there are no chance to become P as a 0 integer. That is, P cannot be 0 here. So root 2 equal to Q by P, where P not equal to 0. Hence what we got? Q equal to an integer by another integer. Then is it possible root 2? No. Why? Root 2 is a irrational number that is known by us, which implies root 2 is rational. Then what? Here we arrive at the contradiction that root 2 is irrational. So we get something wrong by going in this way. Then our assumption is wrong. So what we can prove here? 1 by root 2 is a rational number. Okay. Hence 1 by root 2 is a irrational number. Okay. So what we have to do? We have to apply the method of contradiction first. Then we have to assume 1 by root 2 is rational. Why we are applying this method of contradiction? We have two and only two possibilities. That is, either 1 by root 2 is rational or 1 by root 2 is irrational. You have to keep in mind this. Okay. Then our next question, that is 7 root 5 is irrational. In the same method we will proceed this. That is, we prove this result by the method of contradiction. For that, what we have to assume? 7 root 5 is a rational number. Okay, then what is 7 root 5 then? 7 root 5 equal to P by Q, where P and Q are integers and Q not equal to 0. Another thing, which is CF of P comma Q equal to 1, P and Q are coprimes. Okay, then how to reach our result here? We have to take in all integers to one side. Okay, and irrational to one side. Okay, then root 5 equal to, that is P by Q equal to 7 root 5. Then root 5 equal to, by taking all integers to one side, we will get root 5 equal to P by 7Q. What this imply? Root 5 equal to an integer by another integer where 7Q not equal to 0. Since Q not equal to 0, 7Q not equal to 0. Then what we can prove then? So we are proceeding with our second question. That is root 5 equal to P by 7Q. Then what next? If root 5 equal to P by 7Q, P an integer, 7Q an integer, 7Q not equal to 0, then what is next? Hence root 5 is rational. Okay, which is a contradiction to fact that root 5 is an irrational number. So our assumption is wrong. Okay, since root 5 is irrational, we cannot prove this is a rational number. So it is a contradiction to our assumption, contradiction to the fact that root 5 is irrational, so our assumption is wrong. Then what we can conclude? 7 root 5 is a irrational number. Okay, hence we proved our result. Next, our third problem. In similar method, we are proceeding this. That is, we prove this result by method of contradiction. For that, at first assume 6 plus root 2 is a rational number. Then what is 6 plus root 2? Which is equal to p by q, where p and q are integers and q not equal to 0. Also, HCF of p comma q equal to 1 and p and q are coprimes. How to proceed this? In similar method, we are taking all integers to one side. Then what is root 2 then? That is 6 plus root 2 equal to p by q. Then what is root 2 then? P by q minus 6 equal to root 2. Okay, which is equal to p minus 6q by q equal to root 2. That is root 2 equal to an integer by another integer where q not equal to 0. Then what is root 2 by this definition? It is a rational number. Is this correct? No. Why? Root 2 is an irrational number, which is proved already. Okay, which is a contradiction to the fact that root 2 is irrational and our assumption is wrong. What is our assumption? 6 plus root 2 is a rational number. Okay, so what we can conclude? 6 plus root 2 is irrational. So, how we arrive to the result? That is by finding a contradiction to some facts. Okay, by moving a method that 6 plus root 2 is rational, we will get a contradiction at this point, that is root 2 is an irrational number. Okay, so keep in mind, if you need, you have to add the proof of root 2 is rational, root 5 is irrational. That is, especially in examination point of view, or if you are providing the proof of something like this. Okay, here we are not providing this proof because in this chapter itself we have proved this thing earlier. Okay,